Hello everyone, let's get started. Here's your warm-up. Pause the video, complete your warm-up, and then unpause it to go over it. All right, so all these questions are based off the last lesson that you did, mostly because there were some mistakes and misconceptions. So let's take this. So first question is simplify 3x to the fourth divided by 2x. Here we're recognizing that we are dividing, right? So we have to think, oh, what can we do when we divide? If we have the same base, we subtract the exponents. Before we separated our coefficients and our variables, our like terms, just to kind of clearly see this. So 3 over 2 is the same thing as 1.5 or 1.5, so we can leave that in a decimal. Again, we ask ourselves, x to the fourth divided by x. We are dividing and the bases are the same. That means we could subtract the exponent. Remember, there's a little imaginary 1 in the denominator. So that's 4 minus 1, which is x to the third power. You could have left it as 3 halves x to the third power as well. Both answers are correct. Number 2. Same idea. We're going to break it up. 4 tenths times y to the third over y to the fifth. 4 over 10 we can write as a decimal, which is 0.4. Use a calculator if you can't do that in your head. That's fine. Then we look at our second term here. We know we're dividing. We see that the bases are the same. Since both are true, we can subtract the exponents, which is y to the negative 2. We're going to leave the negative there. We'll talk about negatives later. We could also simplify the fraction 4 tenths to 2 fifths. So we can write as 2 fifths y to the negative 2 as well. So both of these are correct. Okay. You could also take these and you can kind of do them without writing them all out. You can see like, I'll do my coefficients first, which gives me 2 fifths. Then I could do my variables, and then that will give me y to the negative 2. So you don't have to break it up, but I'm going to show you both steps. Here's the problem set for today. So pause, do these on your own, and then we'll go over them together. All right, here we go. Let's take a look at number 1. Again, you can kind of line these. They're already kind of lined up, so we could see our coefficients, 3 over 12, which is 3 divided by 12. Then we'll deal with x squared divided by x, and then y to the fourth divided by y to the seventh. I like to break it up just because it's a little bit easier for me to see. So I have 3 to the 12th, 3 twelfths, or 3 divided by 12, times x squared over x. I'm going to put imaginary 1 because there's always an imaginary 1 there. Y to the fourth divided by y to the seventh. 3 to the 12th can be simplified to 1/4 or 0.25, so I'm going to put it as a decimal. That's what we've been doing. Then we have x squared divided by x to the first, which is just x, because if we see we have the same, we're dividing and we have the same base, so we're going to subtract those exponents. Next, we have y to the fourth divided by y to the seventh. We ask ourselves, are we dividing? Yes. Are the bases the same? Yes. Then we can subtract our exponents. 4 minus 7 is y to the negative 3. Now, if you are having trouble with your integer calculations, use a calculator. Use a calculator. It does not matter. You can use a calculator. You can also write this as 1/4 x y to the negative 3. If you're having trouble with a calculator with positive and negative numbers, please reach out to us, and we'll show you how to do those. Okay. Next, 2. 7 to the third times 7 squared divided by 7 to the fourth. This one, some people had trouble with. You could do this 2 ways, so I'm going to show you both ways. So one way is to write that first number as a fraction, right? Any number can just be written as over 1. So now we can actually multiply across. We can do 7 to the third power times 7 squared all over 1 times 7 to the fourth. All we're doing is multiplying fractions. We multiply the numerators, then we multiply the denominators, and then we can simplify. So now when we're looking at this question, we see 7 to the third times 7 squared. We see that there's multiplication. We see that the bases are the same. That means we can add the exponents. So now we're left with 7 to the fifth divided by 7 to the fourth. Now, on that bottom there, we're just going to multiply because 1 and 7 are not the same base, and 1 times anything is anything. Now we ask ourselves again, well, what can I do here? We notice that it is division, and the bases are the same. Since it's division and the bases are the same, we can subtract the exponents, which is just 7. 7 to the first power 2, but you don't need that first. Excellent. Another way that you could have done this is you could have divided first, right? It's 7 to the third divided by this whole thing. So if you did that, you could see that we're dividing and the bases are the same. 2 minus 4 is 7 to the negative 2. Here we can see that we're multiplying, the bases are the same. And 3 plus negative 2 is just 7 to the first power, or just 7. All right, let's take a look at number 3. It's the same idea. You have to really just recognize what rule are you using. So when we look at this, I'm going to deal with the left side and then go to the right, right? If we're multiplying and dividing, we're going to go left to right in the order of operations. So first we see that it's y to the 7th divided by y to the 5th times 5y cubed. So when we look at this, we ask ourselves, what is the operation? The operation is division. Since we are dividing, we have to check if the bases are the same. Yes, the bases are the same. They're both y. That means we can use the quotient rule. Y to the 7th divided by y to the 5th is y squared, because 7 minus 5 is 2. Now we're left with y squared times 5y cubed. Again, we ask ourselves, what's the operation? Multiplication. We ask ourselves, is there any common bases? And yes, there are. So this is a little different. If you remember, there is a coefficient in front of that first one, and we can reorganize this, right? So when we have coefficients in our problem, we look at our coefficients first, and we can multiply them. 5 times 1 is 5. Then we look at our exponents that are like terms, y squared and y cubed. Since they're the same base, we can just add the exponents y to the 5th power. Lastly, number 4, finding the value of n. There's two things going on here. One, there's division. One, there is multiplication. So when we look at the operations, we see division here, and we see same base. We know this is going to deal with the quotient rule because it's division and it's the same base. On the other side of the equal sign, we can see that it's multiplication and it's the same base. That should click and think, oh, we can also use the product rule. Right? And we can kind of split it into two problems, and they're going to kind of relate to each other. So let's go back to the left side. If it's the quotient rule, that means we can subtract the exponent. So 2 to the 8 minus n. We don't know what n is, but we can write it that way. For the product rule, we see we're multiplying and it's the same base. We can add our exponents, 3 plus 2, which is 5. So now we have another equal thing. We have 2 to the 8 minus n equal to 2 to the 5th. So we kind of we have our own little equation here. 8 minus n has to equal 5. So we can actually write our own little equation here. Well, what must n equal in order to equal 5? 3, because 8 minus 3 is 5. Excellent. Awesome. Okay, you're going to get started on that Desmos, and that is it. Please reach out if you have any questions, and talk to you later.